Hello everyone. So let's start solving today's problem. So we have find the string in grid. All right. So we have been given a 2D grid of dimensions and cross M and a word. Now all we have to do is to find the occurrence of that word in the given 2D grid, right? So the word can be matched in 8 directions and word is said to be found in a direction if all the characters match in this direction. So for example, let's consider the case of second test case. We have A, B, A, B, then A, B, E, B, and E, B, E, B. And the word we have to find is the ABE, right? So this ABE can be found out like this. Another possibility is like this, and another one is like this. So this ABE word exists in the matrix 3 times, and the indices we have to return where it exists is, so let me mark the indices first, 3. So we have to return the indices where the first character starts. For example, this ABE starts from 0 comma 0, right? So one answer is 0 comma 0. The other possible answer is 1 comma 0, right? Because the first character of this string ABE starts from 1 comma 0. Another is 1 comma 0, and the last one is 2 comma 0, right? 2 comma 0. So let's confirm the output. So it's 0 comma 2. My bad. So the first character A starts with 0 comma 2, right? So that's why. My bad. Let me erase this. It's 0 comma 2. So we have to return the index of the character A if this, so let me write it down. If our string gets matched with the given word, right? So if we have the ABE in the grid, we will simply return the index of the first A we have found so far, right? And we have to return it in lexicographically. Okay, so let's think about the approach now. So for any word we have been given, what are the possible ways we can, suppose this is the grid, what are the possible ways we can find out the word? So we have been given that word can be found diagonally. So this is one possible way. Another possible way is to finding out it vertically. Next possible way is to find out horizontally. Okay. So if you look closely, we have like one of the direction is here, upward. Word can exist upward, or also we can search it in the upper right direction. Similarly, downward right, the right direction, downward left, downwards, left, and upper left direction. So these are the possible, what can I say, possible ways, possible paths in which we can search the word, right? So let me tell you the brute force approach in which I'll be solving this problem. So we'll be exploring all these directions and finding out the word, as simple as that. So the idea comes up that in order to find the given word, suppose ABE, we'll be traversing in all the paths which are possible in which the word can exist. And as soon as we get the word, we simply return the index, okay? And then we move on because there can be, we have to find the number of possible ways, right? As you can see, 0, 0, 0, 2. So all the directions, right? So the code will be based on this idea in which we'll be exploring all the paths and finding out the word. Now, let me show you the code now. So I have taken two vectors. This is the direction vector. So while going to the, what can I say, towards the downward left, sorry, upward left, we will have our I minus 1 and our j minus 1, because I and j, row and column, both will be decreasing. If we have rows like this and we move in upward direction, clearly our rows will decrease. Similarly, if we move in this direction, not only our column but also our rows will decrease, right? So that's why if we move a cell towards this direction, we will have minus 1 comma minus 1 coordinate. Similarly, minus 1 comma 0 for minus 1 for the moving in upward direction for row, and 0 for column remaining constant. All right. Then we have minus 1 comma 1, which means our column is getting incremented by 1 and our row is getting decreased by 1. Okay. And similarly, you can explore the rest of them. So we have all the possible. So the order of these directions is not important, but make sure you pair them up correctly. For example, minus 1 should be together, and minus 1, 0 should be together. So in this way. Okay. So first of all, let's look at the main function in which I have declared a 2D array in which I have to return my answer. I have taken the size of the matrix. Now it traverse the whole matrix, and if I have declared a search function which will be searching my given word in this grid. So, and then I'll be, if it is true, which means that if the search has been successful, the word has been found, I will simply push it in my answer and I will return the answer. Now let us look at this search function, what it is doing. So this search function takes my grid in which I'll search the word which I'll be searching for, the I and J, you can see, and the NM. NM is nothing but size. Okay. So if the current word means the starting word does not match, then I simply return false, which means I have to get at least one word which gets matched, right? Then only I can search for the further letters in the word. Okay. So it will return false if my first letter does not match. And if it does, if the first letter does, then I will calculate the new direction, which means, let me show you here. If it were A, B, C here, and the word we have been looking for is ABB, so I will, A gets matched, right? Then only we have come to this line. So we will look for the other letters in all the possible directions. Okay, here, 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 and here as well. Okay, so that's why we have taken a loop from 0 to 8, since there are 8 possible directions, right? So that's why 0 to 7 we have a loop, and we'll be calculating our new I and j, and my index will move throughout the word. Okay, So initially my index is here because the first word has been matched. Okay. That's why I have not started the loop from zero because the first letter of my word has already been matched. Now, if I check if my x value and y value is in the range, if it is not, then I simply break. Okay. Otherwise, if they are in bound, then I will simply add the means the direction in my x and y. So this if statement also checks if my current word present in the grid, if it does not match with the letter in my word. Okay. So this will only execute if the word present at the grid, means the letter present at the grid x and y, matches with the index of the word. So if it does, then I simply again add the directions. Okay. And if the index, which means that if the index has iterated over the whole, means whole word, if my index is out of bound, then my index will be equal to the word size, right? Which means I have found my word. Then I will, in that case, I will return true. Otherwise, I'll return false. So have you understood this solution? So let's submit this code. So it's working fine. All right. Thanks for watching. See you in the next one.